Okay, so the idea in here is the same. We create an object of the LDA class, and we put the model on our X and Y. And then we get the predictions and the predictions probabilities of our observations to be on class 0 and 1. And then we plot the confusion matrix, and the procedure is pretty similar as we discussed during the logistic regression session. In here, you can see that our model was actually also good at classifying the zeros as zeros and the ones as ones, but we have an increased rate of misclassification in here when our label was 1 and our prediction was 0. And we have decreased rate of misclassification in here while our actual label was 0 and the prediction was 1. So in logistic regression, we have 4, 4, and here we had 18 and 2. Let's look at the classification report in here. While you remember, we had some pretty good precision scores for class 0, and we had some good recall, and almost all values are about 0.98 in the logistic regression model. The LDA provides some different results of classification report, and we have 0.95 and 0.99 as our precision recall for our class 0, and we have 0.98 and 0.91 as our recall score. So different classification algorithms like use different approaches, and this is pretty normal because sometimes one model works better than the other one, and there are different explanations for that. For example, the approaches of the models, the distribution of the data, and the preliminary assumptions that our models use while moving on. So looking at the log curve and the precision recall curve of our LDA model, and here the idea is the same. Like we can see that we have also high AUC in here for class 0 and 1 of the log curve and the precision recall curve in here. And when we plot the log curve and the PR curve, we see that of course the model is a good one. Somebody asked about a good model in the beginning. Of course, the model in here is a good one, and we can use this model as a classification model to classify the data. But when the question becomes to choose between LDA and the logistic regression and to compare those, we can clearly state that the logistic regression provides better accuracy scores in here, and the logistic regression has a balanced misclassification rate in our confusion matrix. And we can say that despite the fact that logistic regression works fine, the LDA also works fine, but we have unbalanced misclassifications in here, and the accuracies are not as high as in the logistic regression method. So if I had to choose between those two models, I would choose the logistic regression. Okay, and And the QDA is the implementation of the QDA is pretty similar to the LDA. We just use the quadratic discriminant analysis method in here, and we move on using the same procedures what we used in the LDA and the LR models. We while plotting the confusion matrix in here, we can see that the confusion matrix and the misclassifications, I mean the true negative and false positive weights of our, uh, sorry, false negative and uh, the true positives and the true negatives are pretty high, and the false negative and uh, false positives have changed. And comparing to the LDA model, we can see that, so here we have 2 and 18, and here we have 5 and 10, and we see that this confusion matrix is more similar to, I mean, the distance of this matrix from the one in the LR is uh, is smaller than the distance of this matrix to the one provided by the LDA. So this model is quite, based on the confusion matrix, of course, is quite similar to the LR results, and we can see some balance, I mean, uh, if we had in here the one misclassification rate was nine times more than the other one. In here we have if that this factor equal to 2, which is quite better. And while we look at the classification report, um, we see 0.97 and 0.98 as precision and recall scores, and 0.97 and 0.95 for the class 1. And we can, when we compare this results to the LDA, we can see that despite the fact that the recall in here is 0.99 and the precision for the class 1 is 0.98, in here we have some deprecated results. We have more adequate recall score for the class 1, whereas the recall score in here was 0.91. And we can see more balanced misclassification rates in here. And while despite the fact that of these 3 models, the LR performs the best, between LDA and QDA, I would go with the QDA because uh, uh, the difference in here is also small, and we have some, on average, we have better precision and recall results. And while looking at the F1 score in here, we have 0.97 and 0.96. And
excuse me, in precision, in QDI precision and recall is greater than LDAS in QDA.
AUC what?
In QDA, precision and recall is greater than LDAS. Yeah,
Yes,
for
yes.
classes. Okay.
In QDA, the precision, sorry, this is 0.97 and 0.98, and this is QDA. The precision is greater, the recall not, but the classification report is, I think, the better one than in the LDA.
Yeah, two and eight.
I cannot hear you. Can you just?
I mean, The best model is the one which we have balance in the misclassification, or for example, we have false positive in the LDA. The false positive is smaller than QDA, but mm,
You mean how to choose the best model out of these two?
yes, for example, if in the LDA we have it's false positive, or I don't know. The two, the number
Uh,
of two is I think is
you can remember, you cannot call them just two
yes.
positive, two negative, but you can just say that the rate in which the actual label was 0 and the prediction was 1
Mhm.
uh, was smaller than during the QDA. But in here, the cases when the actual label was 1 and our prediction was 0, uh, uh, we we have a smaller value than the during the
Mhm.
LDA model.
So
So
QDA is better.
so both are actually performing well, but if I were choosing the one of those out of two, I would choose the QDA because there is a balance in the misclassification rating here, and also we have uh, on average we have higher precision and recall for both classes. I mean the trade-off is higher. So we have 0.97 and 0.995 and 0.9798. And in here we have 95, 99. Only this value is greater in here and by 0.01, and the precision is greater by 0.01, but the recall in here uh, actually compared to uh, the recall provided by QDA is smaller.
Can I ask another question about the threshold for all of these models? Um, what is the threshold for all of these models? It's default value of
By
zero point
default,
0.5.
actually, I don't know the threshold value for the default threshold value for the QDA and LDA and the scikit-learn, but for the LR model, it's 0.5, the default threshold value.
Thank you.
Okay, and there is nothing more to tell in here. We just look at the Vogon PR curves and make some comments, and I guess you would be asked to comment on the comparison of the Vogon PR curves, and you just have to look at the values and the curvatures of those two curves and make some statements about that. And finally, we have K and N as our four classification algorithm in here. And as you remember, K and N takes the value of K as the number of neighbors that our model should use to assign a label to a new data observation. And we also should estimate um, I mean, not always were required, but uh, I guess you might be required uh, to be able to estimate the value of k using k-fold cross validation, and that's why we use the x and y into the testing and training set, and the idea is pretty same as we did for the c parameter in the LR model. And here we can just use the NP range uh, to generate a NumPy array containing the values of k from 1 to 25, and we can iterate over these values and construct an object of k&n of the k neighbors classified class in which the neighbor's value is equal to val, which is every and each component in this k value list. So we use k-fold, and the number of splits in here is 10, and we also try to estimate the cross-validation score using k&n as our model, x train and y train as our input data, and the CV equal to k-fold as a tenfold cross-validation parameter, where we try to estimate the accuracy. So as it was for the C, in here also we have score as a list of the cross-validation scores, in which we have a cross-validation score corresponding to each fold of k-fold cross-validation, and we're actually interested in the average cross-validation score to understand for which k we have maximum average cross-validation score. And in here, while we print the value of k and the CV score average, that is the NP dot mean of these scores for each k fold, we see that we have some accuracy scores in here, and we can see that the k equal to 7 is the value of k that provides the highest average accuracy in here. So so here we can use the same idea of NP argmax to get the maximum score, the index of the element corresponding to maximum accuracy score in here, which is 7. But while we plot the k values on the x-axis and the average accuracy scores for each k, the cross-validation scores, we see that we have a peak in here, which corresponds to the value of 7. So the 7 is the optimal value of k, which corresponds to average to a highest average accuracy score. So that's why we build a model, optimal k&n model, using 7 as an input parameter to the n neighbors. We fit our k&n model to x and y. Of course, here you are free to split the data set into train and test initially, and feed the k&n into the x train and see the report in here, and then feed the same k&n with 7 as an input parameter to n neighbors into the test set, and then make predictions and see the comparison of the model on two data. So in here we see that we have no better confusion matrix that we had during LDA, QDA, and logistic regression, and we have 4 for the LR. And we see that the rate in which the true label was 1 and the predicted label was 0 has increased, and the rate at which our actual score was 0 and the predicted was 1 has also increased. And we can see the precision and recalls have decreased with respect to the other models, and here also. And we can see the F1 score is also has also decreased. So while plotting the despite the fact that we have an adequately high AUC scores for the ROC curve of each class, we can see that uh, we have some curvature in here, which actually decreases the area under the curve, and that was like predictable. And in here also we have uh, we see that the PR curve is also different from the other models. And in here I just plotted the ROC curves of the four models. Just a second. Okay. Or we upload the ROC curves of our model side by side. We see that the 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 logistic regression in here provides actually the best ROC curves for each class out of these four classifiers. And although we have good and acceptable forms of ROC curves for all of the classifiers in here, but the one providing the maximum accuracy was the logistic regression, because the as the angle in here is sharper, we have area under the curve maximized. So in here also I plotted the PR curves, and we see that the trade-off between recall and the precision is highest for each class while using the logistic regression model, and they're more less than using the other classification methods. So here, as a conclusion, we can state that out of these four, logistic regression was the best performing model, although the other ones were not so bad. And we can like also move on using the best three models. But we cannot, for example, predict whether, for example, if we increase the number of entries in our dataset, and say, for example, we have like 2,000 of observations of breast cancer data, we cannot say that, for example, logistic would be also the champion among these four, while we have a size of the dataset. So for this current situation, I would go with the logistic regression, and that's all. Do you have any questions? If no, yes.
About the description function, in description function we use as argument the probe, y probe. Why we don't use y prediction, not and but
Hatırlarız kız bit.
in the description function when we want to measure when we want to have measures as recall precision, the argument is y probe, not y predict. Yes. Um, O zaman limanın ancient function description function image probe equal argument parameter value roște predictor. Edit bana theoretical
Verster, ha?
frontier.
Ha?
որ ուզում են, չէ, հենց այս
Ստեղ
report-ի մեջ prediction ենք տալի,
classification report-ի մեջ
prediction ենք տալի, իսկ բանի մեջ FPR, այսինքն rock curve-ի մեջ predict probe ենք օգտագործում, այսինքն արդեն այն շատ theoretical են, չէ, որ պիտի
ես չգիտեմ, էլի library design-ը տենց էլի
okay
implementation-ը պրոստը տենց
լավ
Որովհետև rock curve-ը իրականում ուզում է ամեն մի threshold-ի համար trade-off հաշվի precision-ի ու recall-ի իսկ classification report-ը
threshold-երը տարբերվում են,
ինքը threshold-երը փոխելով ուզում եմ մի հատ հասկանալ, օրինակ threshold-ը որ 0.5 է precision ու recall-ը իրանց ոնց են պահում հետո որ ասենք 0.5-ը շատացրեց իր classification-ը ոնց է փոխվում But probability-ները չունենա, ուրիշ ձև չի կարա որոշի, էլի այդ precision recall-ի curve-ը, որտեղ օրինակ եթե մի հատ value 0.6 է, իսկ threshold-ը 0.5 է, threshold-ից վերև ենթադրենք մոդելը assign-ը անում, եթե probability-ն օրինակ logistic-ի կամ ինչ-որ մի բանի դեպքում, classifier-ի դեպքում, probability-ն օրինակ 0.6 է ինչ-որ այսինքն 0.5-ից վերև assign-ը անում մոդելը class 1-ին ու ինչ-որ մի հատ observation կա 0.6 է, հետո որ threshold-ը փոխեց 0.7, արդեն փոխվում է այդ բանի, էլի, այդ observation-ի class-ը ու եթե probability-ներ չունենա, չի կարա իմանա, էլի, չի կարա չափի ու գծի rock curve-ը։
Հասկացա։ Իսկ predict-ի մեջ արդեն մենք չգիտենք ինչ threshold-ից է օգտվում, չէ՞ որ սա լինի։
Իրա default threshold-ից է օգտվում մոդելը։ Իսկ այս մի հատ թեմայից դուրս հարցնում կոնդենս հա ժողովուրդ եկեք անգլերեն ասեմ էլի I forgot to tell that the plot confusion matrix I guess yes I guess plot confusion matrix method is only available starting from the scikit-learn version 0.22. If you have issues, then just upgrade this package. And we can discuss this issue at the end, RP. Okay. This was the binary classification, and we know that we have also a multi-class classification, and we should also learn about the classifiers and their abilities to perform classification on multi-class data.